Moving on to the max VCG, that's the max VCG means how high up is the vessel's center of gravity allowed to be without being in breach of the stability criteria. And we have this graph here that displays the maximum allowed VCG and compares it to the actual VCG for the 6 calculated conditions, thus giving us an idea of the safety margin for the different conditions. And when we compare the actual G with the maximum permitted G, we have a good indication of safety margins under different loading conditions. And we see here conditions 1 and 2, light conditions, have large margins of safety, whereas in condition 5 and 6, fully laden, there is less, smaller margins. And you, as a captain, you need to be aware of the margins in the loading condition that you are at all times. Going into the different conditions, loading conditions, we start out with the lightship condition. This is all in English, so that's very handy. We see that the vertical center of gravity in the lightship condition is 2.482 meters above the baseline. We see a displacement of 32.88 metrical tons. We see that the GM solid is 9.811 meter. GM solid means that there's no not taking account of free surface effects. The floating status, we see draft forward, midships and aft, and we see that we have 0.18 meters of aft trim. GM solid 9.811, and there's no free surface correction, obviously, since this is a lightship conditions and all tanks are empty and thus no free surface. The G-set curve looks like this, and below the G-set curve you check whether the stability requirements are satisfied. And we have a look at there's, as we can see, there's 6 requirements, and number 4 is that the apex of the G-set curve should be at a greater angle than 15 degrees. It is at 20 degrees. Number 5, G-set should be greater than 0.2 meters at the apex or 30 degrees. It is 1.881 meters, and the GM should be more than 15 centimeters. It is almost 10 meters. So yes, all the stability requirements that we can relate to are most certainly fulfilled. The extent of the G-set curve we cannot say. The curve only goes to 50 degrees, so we don't know the full extent, but it is at least more than 50 degrees. Looking at condition 1, which is 100% fuel and water in the tanks and consumables, but no deck cargo. You have a vertical center of gravity at that's 2.344 above the baseline. The displacement is now 38, almost 39 tons, and a GM is reduced from almost 10 meters to 8.4. Floating status, we now see that we have a little bit of forward trim. Loading summary shows both the lightship center of gravity fore and aft, that's the LCG, longitudinal center of gravity. Transverse or thwartships center of gravity, that is from the center line, and then the vertical center of gravity, which is the center of gravity's coordinates above the baseline. So lightweight, that's lightship, that's the weight of the empty ship. Dead weight, that's all the weights that we take on board. In this case, fuel, water, consumables, and the displacement then is the sum of these all these weights. The G-set curve looks like this. We check the values, the criteria against the minimum requirements. We see that the apex of the G-set curve is at 22.2 degrees. G-set 1.875 at its apex, and the GM is 8.4 meters, so less than in the lightship condition, but still sufficient. Looking at condition 6, which is full deck cargo and 10% fuel in the tanks. We see that the center of gravity is now up to 2.9 meters. A displacement has increased to 58 tons. The GM is all the way down to 4.9 meters, so it's almost half the size of the lightship GM. Floating condition, draft has increased, and we see now that we have a free surface correction, 0.3 centimeters, so not very much, but it's still there. The center of gravity for the different categories of weights, and the GZ curve. If we compare this to the GZ curve in condition number 1, we can see that the GZ curve for condition number 6 is significantly lower. And it's difficult to really see this without actually comparing the values of the curve, because the shape of the curve is exactly the same, so you have to look at the numerical values of the apex in order, or compare them side to side like we've done here, to see that the GZ curve is, or the stability is significantly weaker in condition 6 compared to condition 1. But still, the stability requirements are definitely satisfied. So the stability of the vessel is still good in condition 6, but in this condition you can't use the crane at full power. The reason for this, if you go further into the data, is that you get so much heel that you have a freeboard of less than 0.2 meters if you use the crane with a greater torque than 17 ton-meters. And this is when the crane is pointing diagonally aft on the starboard side, typically the weakest point of a crane. So to summarize, the Nabcat GM is between 9.8 meters and 4.9 meters. We do not know the full extent of GZ, but we can see that it's positive up to at least 50 degrees of heel. In condition 6, though, the GZ is considerably smaller than in condition 0. The max VCG shows us really well that the margins of safety are significantly less when the vessel is fully laden. The freeboard, of course, is reduced with increasing displacement, and in conditions 5 and 6 there are restrictions on the use of the crane. Total good stability, but you need to be aware of the restrictions that apply, particularly when you're fully laden.